Welcome to this training module on the CDP Public Cloud Foundation. In this session, we will explore how Cloudera extends the modern data platform to the public cloud, enabling a true hybrid architecture. We will cover the core concepts of the control plane, the environment, and the critical services that make secure, scalable analytics possible. Let's begin by defining what we are building. CDP Public Cloud is not just hosting Hadoop in the cloud, it is a managed platform as a service. The key concept you must grasp is the separation of concerns. Cloudera manages the control plane, the brain of the operation that handles orchestration, management, and identity. However, the actual heavy lifting, storage, and compute happens inside your cloud account, whether that is on AWS, Azure, or Google Cloud. This architecture ensures that while Cloudera manages the platform, you maintain absolute sovereignty and control over your data. This foundation enables a true hybrid data fabric, allowing you to move workloads between your data center and the cloud as business needs dictate. This diagram illustrates the high-level architecture. At the top, we have the Cloudera control plane, which acts as the central management hub. From this single pane of glass, it orchestrates resources across the major public clouds, AWS, Azure, and Google Cloud. Notice that the arrows point downward. The control plane instructs your specific cloud account to provision resources. Ultimately, your data and compute reside securely within your chosen cloud provider, indicated by the bottom node, ensuring data gravity and compliance remain under your control. Why should an enterprise move to CDP Public Cloud? The primary driver is the decoupling of compute and storage. In legacy on-premises clusters, these were tied together. In the cloud, they are independent. This allows for true elasticity. You can spin up a data warehouse for a specific report, run it for an hour, and then suspend it, paying only for the active time. Furthermore, CDP integrates natively with cloud object stores like Amazon S3, Azure Atlas, and Google GCS. This means your data is durable and accessible, not locked inside a proprietary file system, enabling a data lakehouse architecture where multiple engines can access the same data simultaneously. Here we visualize the efficiency of the cloud architecture. On the left, we have the compute cluster. This resource is ephemeral. It can be suspended or resumed based on demand, as shown by the dotted action line. It connects to the cloud object store in the center, such as S3 or Atlas. This storage layer is persistent and durable. Even if the compute cluster disappears entirely, your data remains safe and accessible in the object store, ready for the next workload to pick it up. To operationalize Cloudera in the cloud, you create an environment. Think of an environment as a logical fence around a specific virtual network in your cloud account, such as an AWS VPC or Azure VNet. It defines where your resources live. To create this, you provide a credential like an AWS cross-account IAM role, which grants Cloudera the permission to create virtual machines and load balancers on your behalf. It is important to note that an environment is tied to a specific cloud region. If you need presence in both the US and Europe, you would register two separate environments. This diagram breaks down the environment structure. Within a specific region, represented by the outer box, sits the CDP environment. It acts as a container linking two critical components, the credential IAM, which provides authorization, and the virtual network, VPC or VNet, which provides the infrastructure. Inside this network, the environment hosts the data lake and the various compute workloads, ensuring they all share the same network security boundaries. Security is often the biggest hurdle in cloud adoption. Cloudera solves this with SDX, the shared data experience. When you create an environment, CDP automatically deploys a data lake cluster. This isn't just storage, it's a running cluster hosting Apache Ranger for security policies, Apache Atlas for lineage, and the Hive Metastore for schema definitions. The beauty of SDX is consistency. You define a security policy once, say. Only HR can see salary data, and that policy is automatically enforced across every workload, whether it's a data engineering job or a data warehouse query, eliminating the need to secure each silo individually. Visualizing SDX as the central pillar of trust. At the top is the SDX data lake, housing the critical governance services, Ranger, Atlas, and the Hive Metastore HMS. Notice how the arrows flow outward from Ranger to the various compute services like data warehouse, data engineering, and machine learning. This signifies that the security context and policies defined in SDX are inherited and enforced by every attached workload, creating a unified security posture. In CDP Public Cloud, you have two ways to run workloads. First, there are data hubs. These correspond to the classic cluster experience clusters of virtual machines running services like Kafka or HBase. They are highly customizable and give you granular control. Second, we have data services including data engineering, data warehouse, and AI. These run on Kubernetes and offer a serverless-like experience. You don't manage the cluster. You just submit queries or jobs. The data services handle auto-scaling, upgrading, and resource isolation for you, allowing your teams to focus on the data, not the infrastructure. This decision tree helps you choose the right workload type. Starting at CDP workloads, you split into two paths. On the left are data hubs, which are VM-based and customizable, ideal for lift-hand shift or specific tuning needs. On the right are data services, which are Kubernetes-based and offer a serverless-like experience. This modern path reduces operational overhead and is the preferred method for standard analytics and ML tasks. A common question is, how does Cloudera manage my cluster if it's in a private network? The answer is the Cluster Connectivity Manager, or CCM. Instead of opening dangerous inbound ports in your firewall, CCM uses a reverse tunnel architecture. An agent running inside your private VPC establishes a secure, outbound connection to the Cloudera control plane. All management traffic flows back through this pre-established tunnel. This architecture allows you to deploy fully private clusters on AWS, Azure, or GCP with no public IP addresses, satisfying the strictest security compliance requirements. Let's trace the secure communication flow. We have the control plane on the left and your private CCM agent on the right, separated by a firewall. Note that the firewall blocks all inbound attempts from the outside. The communication starts from the agent inside your VPC, which initiates an outbound tunnel over HTTPS to the control plane. Once established, the control plane can send management commands back down this secure pipe, and the agent returns status updates, maintaining connectivity without exposing your network. Ready to build? Here is the logical workflow. First, you set up your cloud credential and IAM role or service principal that gives Cloudera permission to act. Second, you register your environment, pointing Cloudera to your specific VPC and region. This step automatically triggers the third action, the creation of your data lake. This establishes your security and governance layer, SDX, immediately. Finally, once the data lake is running, you can provision workloads spinning up data engineering, warehousing, or data hubs as needed, all of which will automatically inherit the security context from your data lake. This flowchart maps your journey to a running platform. It starts with the cloud credential. This authorization allows you to register the environment. That action automatically triggers the auto-deploy data lake step highlighted here because it is the foundational step that enables everything else. Once the lake is active, you move to provision workloads, branching out into either specific data hubs or the various data services, ready for your users.